Okay, y'all. In this video, we're going to talk about empirical and molecular formulas. So remember that an empirical formula gives you the smallest whole number ratio. So remember that we have to reduce them down if we can. Molecular formulas are going to be a whole number multiple of that empirical formula. And it's got to be that whole number, so it's got to be in like an integer. And then we will multiply it by the empirical formula, but we'll get to that in a little bit. So we will calculate empirical formulas from experimental data, but we'll also do it from percent composition. So step 1, actually this is step 2, but we'll get to that in a minute, what number 1 is. We're going to divide our masses by the molar mass to get moles. Okay, so when we do this here, we get 3 moles of hydrogen for every 1.5 moles of oxygen. Step 3 is to divide by the smallest. Divide all of them by the smallest. And this is so we get a whole number. Okay, so here are our steps. I do suggest you pause here if you're watching at home so you can make sure you get them down, right? So step 1 is percent to grams. All you do is take the percent sign off and put the gram sign on. Step 2 is grams to moles, so you're going to divide by the molar mass of each element to get moles. Step 3 is you're going to write down the subscripts from step 2. But step 4 is you're going to divide all the subscripts by the smallest. So you're going to divide by the smallest. Step 5 is an if situation. If they're not whole numbers at that point, once you've gone through step 4, then you have to multiply them by another whole number to get whole number subscripts, because we cannot have decimal subscripts. So here's a table. Really, these are the ones you need to focus on. Occasionally there's one you have to multiply by 5, but there won't be any like that on the test or the homework. Alright, so let's do one. This one we get to skip step 1. So I've got nitrogen, oxygen. So I've got 24.5 grams, 70 grams. So I'm going to divide by 14 grams per mole and by 16 grams per mole. So this is step 2, divide by the molar mass of each element. We get 1.75 moles and 4.375 moles. At this point, you do need to keep at least 4 numbers if they cut off, like if it keeps going in your calculator, because if you cut off too soon, then it messes with your values at the end. All right, we're going to divide by the smallest, which is 1.75. This is so we get whole numbers out of it. So nitrogen is 1, oxygen is 2.5. So this is the situation where I cannot have 2.5 as a subscript. So we multiply them both by a whole number. So my answer will be N2O5. Because we cannot have partial number subscripts. Okay, let's do another one. I've got carbon, hydrogen, and oxygen. 165 grams of carbon by 12 grams per mole. 27.8 grams of hydrogen by 1 gram per mole. 220.2 grams of oxygen divided by 16 grams per mole. Okay, we divide by the smallest, which is 13.75. Okay, if it is within a tenth of a whole number, that's what we just deem it as. It's that whole number. So these are whole numbers, which means those are our subscripts, CH2O. Okay, now we have some that start as percentages. So we do the same process. All we do is take that percentage off and put on grams. Okay, so in this scenario, we do all of our steps. We come out, carbon ends with 0.25, which means we need to multiply them all by 4. So I get C9H8O4. Please make sure to ask if y'all have questions. Okay, occasionally they're going to give us values, and like this, instead of percentages, normally we get percentages. But here it tells us we've got this 3.24 grams of titanium in the metal oxide and 5.4 grams of the metal oxide. So you have to subtract them to get oxygen. So our oxygen amount is 2.16. This is only if they don't tell you all the elements. Remember, percentages add up to 100, so if they don't tell you all the elements for the percentage, they'll tell you all but one, and you'll just subtract them from 100. Okay, so we start with our 2.16 and our 3.24. So titanium is 3.24 grams. Oxygen is 2.16 grams. We do what we've been doing. Titanium is 47.8. I guess 47.9. Yeah, 47.9. So we divide by our smallest, just 0.0676. So I get TiO2. Okay, please let me know if you have questions. We're going to do plenty of practice on this. Okay. As far as molecular mass goes, remember that's got to be a larger multiple, or it could just be a multiple of 1 of the empirical formula. Okay, this is very important. The molar mass on top will be given. For this piece, you will have to calculate it. Okay, so here we're going to find the molecular formula for fructose. We've got an empirical formula it gave us, and here's that molar mass. So N is equal to 180.2 grams per mole. The molar mass of CH2O 30.03. So this should be 6, because remember it should be a whole number multiple. So what I'm going to do with that multiple, I'm going to multiply it through or distribute it. So my answer is C6H12O6. Okay, again, the molar mass will be given, the one on top. The empirical formula mass you need to calculate, and then when you find that value of N, you multiply it by the empirical formula. So let's do another one. N is 128.16 grams per mole. $64.1. My multiple is 2. My answer will be C10H8. Okay, and we've got another one, 58.12. On the bottom, we've got 29.07, which is 2. Multiply that by C2H5, and I get C4H10. Easy peasy. Occasionally, they don't give you the empirical formula. They do give you the molar mass, like I said they would. It's always going to give you that. But here we have to find the empirical formula first. I've got CH4N times some number N. N is 60.06, sorry, 0.10, divided by 30.06, so it's 2. So my final answer is C2H8 in 2. So if we had one like this, it would be multiple steps. And then that's it. Please let me know if y'all have questions, all right?